Hello, today we will be talking about polynomials and polynomial functions by Zhu Chen, Malik Johnson, Frank Paget, and Johanna Siegel.
Today we'll be discussing graphing polynomials by determining their end behaviors, solving polynomials by factoring and grouping, and dividing polynomials using long division and synthetic division.
Our first section is evaluating polynomials. So our first problem is to evaluate f of x equals 4x to the fourth minus 2x cubed minus 3x minus 5 when x is equal to 2. So the first step is to plug in 2 for all of your x values. So you get 2 to the fourth minus 2 times 2 cubed minus 3 times 2 minus 5. So you simplify, you get 16 minus 6 minus 5. Then you simplify even more and you get 0 minus 6 minus 5, and your final answer is negative 11. The next problem is f of x equals 3x cubed plus 7x squared minus 2x plus 4 when x is equal to negative 1. So again, you plug in negative 1 for all the x values, so you get 3 times negative 1 cubed plus 7 times negative 1 squared minus 2 times negative 1 plus 4. And you simplify and you get negative 3 plus 7 plus 2 plus 4. And then you simplify and you get 4 plus 6, which equals 10.
Alright, so our next section is solving polynomials by grouping. In this example, we have x cubed minus 3x squared minus 16x plus 48. And the first step you have to do, you have to factor out common terms. So then you get x squared, parentheses, x minus 3, negative 16, parentheses, x minus 3. Then after you factor that out, you get x squared minus 16, and then parentheses, x minus 3. So you have to find another common term, and then you get x minus 4, x plus 4, and x minus 3. After this, you have to set numbers in that will place the function to 0. So after this, you put you can see if you plug in 4 right here, you get 0. If you plug in negative 4 right here, you get 0. And if you plug in positive 3, you get 0. And then you write down your zeros, and then you complete your problem. So the next section is graphing polynomials. And this example is graph y equals x cubed minus 3x squared plus x minus 2. And the first thing you need to do is to determine your end behavior. And the end behavior is determined by the highest degree. So with the highest degree being to the power of 3, the graph goes down up. And then after that, you should set functions and plug in numbers, probably negative 2 to 2 into the function. So if you plug in negative 2, you get negative 24. You plug in negative 1, you get 7. You plug in 0, you get negative 2. And you plug in 1, you get negative 3. So after this, you should find your x and y intercepts. And when you set x to 0, your y-intercept is negative 2. So you plot that there. And when you set y to 0, your x-intercept is either 2.9 or roughly 3. And then after you plot in these points, you have your graph.
Here's another example of graphing polynomials. So today we will graph x to the fourth minus 2x squared plus x minus 4. And you look at the highest degree, which is x to the fourth. So therefore the end behavior will be up, up. So first you set your table of values, your table of x and y values. And normally you arrange from negative 2 to 2. So if you plug negative 2 back into the equation for x, y would equal 2. If you do the same with negative 1, you'll get negative 6. If you do it with 0, it's negative 4, 1, negative 4, and 2 would be 6. So you plot these points, and as you can see, the graph passes through positive 2 and negative 2 on the x-axis. So your x-intercepts will be positive 2 and negative 2. And the graph passes through negative 4 on the y-axis, so your y-intercept would be negative 4.
Now we will talk about dividing polynomials using long division. First, we will talk about the factor theorem. The factor theorem states that x minus a is the factor if a is the 0 of the polynomial. Our first example is divide x squared minus 3x minus 18 by x plus 3. x times x is x squared, and 3 times x is 3x. We subtract, and you are left with negative 6x, I'm sorry. You bring down negative 18, and then negative 6 times x is negative 6x. 3 times negative 6 is negative 18. You subtract, and you are left with 0. And therefore, x minus 6 is a factor of the polynomial x squared minus 3x minus 18. Our second example is divide 3x squared minus 11x minus 26 by x minus 5. X times 3x is 3x squared. Negative 5 times 3x is negative 15x. You subtract, and you are left with 4x. Bring down negative 26. And 4 times x is 4x. Negative 5 times 4 is negative 20. You subtract, and you are left with negative 6. As you can see, 3x plus 4 is not a factor because there's a remainder of negative 6.
Our next section is factoring polynomials. So the first problem is to factor x squared plus 5x plus 6. So the first step is to figure out what two numbers multiply to be the leading coefficient times the constant and add to be the middle number, the x. So those two numbers for this equation are positive 2 and positive 3. So you write it as x plus 2 in parentheses and x plus 3 in parentheses. Those are your two factors. Our second problem is to factor 3x cubed plus 6x squared minus 9x. So the first step is to figure out, since this is a cube, you have to figure out what factor you can factor out of all of these terms. And that factor is 3x. So you factor out 3x and you get 3x times x squared plus 2x minus 3. And so then your final factors are 3x, x plus 3, and x minus 1. So our last problem is to factor x cubed plus 3x minus 1. So there aren't two numbers that multiply to be negative 1 and add to be 3, so we have to use the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. So you plug in all of your terms for all of these variables here, and you get negative 3 plus or minus the square root of 3 squared minus 4 times 1 times negative 1 all over 2 times 1. So when you simplify, you get negative 3 plus or minus the square root of 9 plus 4, which is 13, all over 2. And so since this is a plus or minus sign, you're going to get two solutions. Your first solution is negative 3 plus the square root of 13 over 2, and your second solution is negative 3 minus the square root of 13 over 2.
Now we will talk about how to synthetically divide. Synthetic division is simplifying a polynomial by dividing it by a linear factor. Only use synthetic division if you are dividing by a linear factor. Today we will use synthetic division to divide x cubed minus 13x plus 12 by 4. The first step will to be reverse the sign of the divisor. As you can see, the divisor is x plus 4, so you will set it equal to 0, which will make it negative 4. Next, you would replace 0 with any missing term. In the equation, you can see that it's x cubed minus 13x plus 12, but there's no x squared, so you will make x squared 0. So you will put negative 4 as the divisor, and your coefficients will be 1, 0, negative 13, and 12. The next step is to bring down the first coefficient. 1 is the first coefficient, so you will bring that down. Now you would multiply the first coefficient by the divisor. Negative 4 times 1 is negative 4. Next, you will add the product of that by the second coefficient. So, like I said, negative 1 times 4 is negative 4. You add 0 plus negative 4, which is negative 4. Negative 4 times negative 4 is 16. Negative 13 plus 16 gives you 3. And finally, negative 4 times 3 gives you negative 12. And 12 plus negative 12 equals 0. And as you can see here, 0 is the remainder. So your quotient would be x squared minus 4x plus 3.
The rational root theorem. We use the rational root theorem to find the possible roots of a polynomial. The rational root theorem is P over Q, and P is the factors of your constant term, while Q is the factors of your leading coefficient. And don't forget about the negative factors. The example that we have is 4x to the fourth minus x cubed minus 3x squared plus 9x plus 10. 10 is the constant term, so we have to find the factors of 10. The factors of 10 are plus or minus 1, plus or minus 2, plus or minus 5, and plus or minus 10. And 4 is our leading coefficient. And the factors of 4 are plus or minus 1, plus or minus 2, and plus or minus 4. And for each of the factors of 10, we divide each factor of 4, and we were left with plus or minus 1, plus or minus 2, plus or minus 5, plus or minus 10, plus or minus 1/2, plus or minus 5/2, plus or minus 1/4, and plus or minus 5/4. And simplify the fractions and take out any repeats if you have.
So our review questions are: what are the steps to graph a polynomial? When would you use synthetic division? What is the rational root theorem? What are some methods you can apply to solve polynomials? What method would you use to divide polynomials? So if you can answer all these questions, you've mastered this section. Congratulations!